Hello, assalamu alaikum everyone. My name is Aisha Khalid and welcome to my channel Math Madness by Aisha Khalid. So today we are going to discuss trigonometric identities, which is part of the paper 1 syllabus of pure 1 math 9709 AS level. In the previous part I discussed the basic ratios and how to interpret them, and in this part I will be discussing identities. So we know that the primary trigonometric functions are sine theta, cos theta and tan theta. Tan theta can be written as a sine theta upon cos theta. Now how many different types of variations can be done in tan theta? So if it's a tan square theta, I can write it as a sine square theta upon cos square theta. If I want to change the angle, tan 3 theta is equals to sine 3 theta upon cos 3 theta. I'm just telling you in how many ways we can do variations with the tan theta. So if you have a tan cube theta, I can write a cube on both the sides. So different variations of tan. Alright, now the first identity that we need to know is sine square theta plus cos square theta is equals to 1. This is also given in the formula book. Now how can we alter it? Different variations of the identity. We can move cos square to the other side, so it becomes 1 minus cos square theta. Now this resembles to a square minus b square, so we can open it up like 1 minus cos theta, 1 plus cos theta. Now another variation is where we make cos square the subject. 1 minus sine square theta. Again we can open it up like 1 minus sine theta, 1 plus cos theta. So we need to know, this is the basic identity. One variation, second variation, third variation, fourth variation. So these variations are used on and off to be used in the identities. Now when I say identities, what does that mean? It means we have to prove that left hand side can be simplified to become right hand side. Now let's take up a question. 1 minus tan square x divided by 1 plus tan square x equals to 1 minus 2 sine square x. Now the first thing is this fraction can be written like 1 minus tan square x bracket divided by 1 plus tan square x. Now tan can be expressed as sine upon cos, and since there's a square on it, so I will write it like 1 minus sine square x divided by cos square x. 1 plus sine square x upon cos square x. Like taking the LCM, cos square x minus sine square x divided by cos square x divided by cos square x plus sine square x divided by cos square x. Now division sign to change into multiplication and reciprocating the fraction. So we know that cos square plus sine square is equals to 1. So this thing becomes 1, cos square cancels out. So this is what we are left with. Now we need the entire thing in sine, not cos. So cos square can be further replaced with a 1 minus sine square x. So we are using the same identity, different variations in just one question. Minus minus is a plus. Proven. And you can ace identities with practice. They don't just come to you like that. Okay, let's do the second question now. 1 plus sine x upon cos x plus cos x divided by 1 plus sine x, 2 upon cos x. So the first thing is, since it's a fraction, we need to take the LCM. So fractions need to be eliminated. They need to be simplified. 1 plus sine x into 1 plus sine x plus cos square x. Multiply the brackets. Now we know sine square plus cos square is equals to 1. One plus 1 is a 2. Let's take 2 common out. I forgot to mention the cos x. Cancels out, so we are just left with a cos x in the denominator, and we have proven what they wanted us to prove. So this is what they want us to prove, and we have proven the same thing. These are all past paper questions that I'm discussing so that you have a better understanding of the questions. Question number 3. So let's take the LCM first. Sin x to be multiplied by 1 plus sin x. I'm doing it directly. Minus sin x to be multiplied with a 1 minus sin x, and the denominator will become 1 minus sin x into 1 plus sin x. This is a minus b, a plus b. A square minus b square. Sine plus sine square minus sine plus sine square. So I'm using an s in place of a sine, writing sine and again. 2 sine square, 1 minus sine square. Now we know that 1 minus sine square is cos square. And sine square upon cos square can close into tan square x. So our identity is proven. Let's do the 4th question now. Tan square x minus sine square x equals to a tan square x sine square x. So first thing is we need to simplify and write tan square as sine square upon cos square. Let's take the LCM. Let's take sine square common out. Now we know 1 minus cos square is also sine square. Going above and showing the identity, 1 minus cos square is sine square. This sine square upon cos square becomes tan square x. So identity is proven. Some more questions. Prove the identity. So this is an a minus b the whole square. So I'll open it up with a minus b the whole square is a square minus 2ab plus b square. Minus 2ab plus b square. Now 1 upon cos square, 2 tan theta upon cos theta plus tan square theta. Now simplify tan. 2 tan is sine upon cos. Tan square is sine square upon cos square. 1 upon cos square. Now that we have cos square in the entire denominator, I'll take that as the LCM. I can clearly see it's a quadratic function. Now let's do middle term breakup for this. I have to plus to make a 2. So minus minus gives you a plus minus 2. Now grouping them and factorizing, taking a minus 1 common out. Now sine theta minus 1 sine theta minus 1 divided by cos square theta. Cos square theta can also be simplified, so I'm simplifying it over here only so that we have a simplified version denominator here. Cos square theta can be written as a 1 minus sine square theta. So I can write it as a 1 minus sine theta, 1 plus sine theta. Now taking the minus sign common out from the denominator, and in the numerator we have sine theta minus 1, sine theta minus 1. This will cancel out. This new sign can be shifted in the numerator. This was a little tricky identity to prove. I'm just showing you the entire thing once again so you understand what steps I've done to prove it. In the next video, I'll be discussing angles, and then we will be doing past paper questions all together, because usually in the first question they expect you to prove the identity and use that identity to solve angles in the next part. Stay tuned to my channel and subscribe it to understand more about Pure 1 Math AS level 9709. Stay tuned. Allah Hafiz.